In this program, we'll light up a single LED strip pixel at a time, changing its position so it looks like it's moving up and down the LED strip. We'll also change the color of the pixel as it moves. Anytime we use the LED strip, we want to include the ledstrip.h library. That gives your program access to special functions like strip.setPixel, .draw, and .clear that are designed to make it easier to code the LED strip. When using the LED strip library, we need to give the strip a name. I name mine strip because that's easy for me to remember and easy to type. We also need to complete the LED strip function. That function has 3 arguments. First, how many pixels are on our LED strip? Second, which pin of MakerBoard is plugged into the green wire of the LED strip? And third, which pin of MakerBoard is plugged into the blue wire of the LED strip? We don't need any code inside the curly braces of the void setup function, but we still need to have that here with an opening and closing curly brace for the program to run correctly. Within the void loop function, we first see a for loop. The for loop has 4 main parts. First, you create a variable and give it a starting value. After a semicolon, you define a condition that is checked every time the for loop runs. After another semicolon, you define a change to the variable that happens after the code between the curly braces runs. And between the curly braces is the code that runs when the condition of the for loop is true. In this case, we're creating an integer or int variable, which means it's a whole number value, no decimals, named I, which is a common counter variable for loops, and it has a starting value of 0. The condition checks if I is less than 15. If that's true, the code between the curly braces runs, and then I++ adds 1 to the value of the I variable. Inside the for loop's curly braces, the first thing is a strip.clear function. That's going to clear off any lit pixels that are on the strip. Next is a setPixel function. The setPixel function has 2 arguments. The first argument is the pixel or pixels that we're lighting up or addressing. This can be any number from 0 to 14, but here we're using the value of the I variable to determine which pixel will be lighting up. The second argument in the setPixel function is a color value that we want to display on the pixel that we're using. This can be anything from 0 to 299 to show a rainbow of colors on the LED strip. Instead of using a hard number here, we're using the value of the variable I times 20. We're going to see a full range of the colors that the LED strip can display because 300, which is the number of color values, divided by 15, which is the number of pixels we have, gives us 20. So if we multiply I by 20, each pixel is going to show a color value that's 20 greater than the last pixel, and by the time we've lit up all 15 pixels, we'll see the complete range of 0 to 299 color values. The .draw function is going to send any data to the strip that's been written. So it's going to clear off the old pixel and then send the set pixel data and display it on the strip, showing us the new pixel that's lit up. After a delay of 100 milliseconds, the for loop reaches its closing curly brace and adds 1 to the value of the I variable, before checking the condition again, and if the condition is true, running the code in the curly braces again. Once I reaches 14, the code between the curly braces will run, lighting up pixel number 14, which is nearest the tip of the strip, and giving it a color value of 280. After drawing that and delaying for 100 milliseconds, I++ will make I 15. 15 is not less than 15, so the code between the curly braces is skipped and this first for loop is completed. The code will make its way to the second for loop. And this for loop has the same parts as the first. First, creating a variable and giving it a starting value. Second, creating a condition that gets checked before the for loop is run. Third, creating a change to the variable that happens after the code between the curly braces runs. And the code between the curly braces, which runs when the condition of the for loop is true. In this second for loop, the variable I is still an integer, and it's a totally separate variable from the one we created on line 13. The condition checks if I is greater than or equal to 0. So I will be true if it's 14 all the way down to 0, because is 0 greater than or equal to 0 is a true condition. The change to the variable here is I minus minus, which subtracts 1 from the value of the I variable when it runs. And the code between the curly braces is exactly the same as the code on lines 14 through 17, using the clear function to clear off any visible pixels, setting the pixel I to a color value of I times 20, drawing that pixel data on the LED strip, and delaying 100 milliseconds. Let's run through the void loop. The first for loop creates an integer I that equals 0. 0 is less than 15, so the condition is true and the code between the curly braces runs. The .clear function is going to clear off any pixels that are lit on the strip, and then setPixel is going to set pixel 0, the one closest to the wires plugged into MakerBoard, to a color value of 0. .draw will display that lit up pixel, and the delay function will pause for 100 milliseconds, or 0.1 seconds, before reaching the closing curly brace of the for loop, and I++ increases I by 1. Now I is equal to 1. 1 is less than 15, so the condition is true, and the strip.clear function is going to turn off that 0 LED that was lit the last time the for loop ran. The setPixel function will set pixel 1 to a color value of 20. Draw it and delay for 100 milliseconds with only pixel 1 lit up with a color value of 20. Pixel 0 has been turned off on line 14 with strip.clear. After reaching the closing curly brace of the for loop, I++ increases I from 1 to 2. The condition is still true, so the code between the curly braces runs, turning off pixel 1, setting pixel 2 to a color value of 40, drawing that pixel on the strip, and delaying 100 milliseconds with only pixel 2 lit up on the strip. Eventually, pixel 14 will be lit, and it will be lit to a color value of 280 with I times 20. It will be drawn and delay for 100 milliseconds before I++ makes I equal 15. When that happens, this condition of the for loop is false, so the code between the curly braces is skipped, and that for loop is complete. On line 21, a new for loop is created. This integer I has a starting value of 14, and as long as I is greater than or equal to 0, we'll run the code between the curly braces and then subtract 1 from the I variable. Remember that at this point in the code, pixel 14 is lit up to a color value of 280. On line 22, the strip.clear function will clear off that pixel that's lit, and the strip.setPixel is going to set pixel 14 to a color value of 280. So it's overwriting it at exactly the same color value and position where the last for loop ended. The strip.draw function sends that data to the strip, turning on pixel 14 to a color value of 280, and after a delay of 100 milliseconds, the for loop reaches its closing curly brace, runs this I minus minus, and now I is equal to 13. 13 is greater than or equal to 0. So the condition is true and the code between the curly braces runs again. The strip.clear function turns off pixel 14 with a color value of 280, and the setPixel function sets pixel 13 to a color value of 260, 13 times 20. The strip.draw function sends that data to the strip, and the delay of 100 milliseconds pauses the program here with pixel 13 shown at a color value of 260. When the closing curly brace of the for loop is reached, I runs again, making I equal 12, and the condition is checked again. Eventually, I is going to equal 0, setting pixel 0 to a color value of 0, because 0 times 20 is 0. That will be shown on the strip and delayed for 100 milliseconds before this for loop comes to a closing curly brace, and I will make I negative 1. Negative 1 is not greater than or equal to 0. So the condition of the second for loop is false, and the program is going to skip the code between the curly braces of the for loop and reach the closing curly brace of the void loop. Next, the program is going to run the first line of code it can find in the void loop, starting over again. So you'll have a single pixel that looks like it's bouncing up and down the LED strip, changing color as it goes.